Okay, let's go ahead and get started with section 5.1. In this section, we are going to consider summary measures, or in particular, measures of location, for a numerical variable. Okay, let's go ahead and get started then. So first, what do we mean by a numerical variable? A numerical variable is a variable, just a set of measurements, that are on a naturally numeric scale. So what do we mean by naturally numeric scale? That might seem pretty simple and straightforward. However, I have an example here that'll illustrate some of the complexities in this definition of naturally numeric scale. So let's consider here just some simple data on newborns. I have the name here of the newborn in column B, and then I have the sex of the newborn here with 1 indicating male and 2 indicating female. And then I have the weight of the newborn, and I got some other variables over here on the right as well. So let us first consider the weight. The weight here is in column D. Is that measured on a naturally numeric scale? And the answer to that is yes, it is. Okay, so how do we know that it's on a naturally numeric scale? Well, there's a couple of tests that we can use, or a couple of things that we can think about. And the first is, do differences make sense between these observations? So for example, Jackson weighed about 2,550 grams, and Sophia weighed about 2,270 grams. We compute the difference between those, which is about 280 grams. That quantity makes sense. We can say that Jackson weighs about 280 grams more than Sophia. So when that difference makes sense, you might be dealing with a naturally numeric variable. The other thing to think about is the quantity 0. For a naturally numeric variable, the quantity 0 typically means nothing or doesn't exist. So in those two considerations, weight would be considered a naturally numeric variable. How about sex of the child? Now, sex of the child is not a naturally numeric variable. And question number 2 asks why not? Well, it's because this 1 and 2 quantity are just codes for males and females. Okay, so they're just indicators for whether or not the child was a male or a female. So let's go ahead and answer this second question. Why is sex of child not on a naturally numeric scale? Well, here, 1 and 2 just indicate male or female. Okay, you can kind of think that they're almost placeholders for the males and the females. Certainly, a value of 0 here doesn't make sense for sex of the child. Would month be considered naturally numeric? So month, we know that 7 is July and 11 is November. So that's pretty common practice to use numbers to identify months. But again, these are just placeholders for July and for November. Okay, the quantity 0 doesn't really make sense for month neither. And the same thing for day. Okay, day is the 6th day, the 14th day, the 29th day. Again, the quantity 0 doesn't really mean that there's not a day. Okay, so according to does the 0 make sense, both of those would fail on the naturally numeric scale. So neither of these would be a naturally numeric scale. Now I will say though that for month and day, differencing does make sense. So when there's a difference of 2 in the months, we know that, well, or for example, the difference here is 11 versus 7. We know that Sophia was born 4 months after Jackson here. So differences make sense when you're talking about month and day, but not the quantity of 0. So there's certainly some gray area here sometimes when we talk about what we mean by naturally numeric. So suppose your friend decides to compute the average here for column C. What would this average tell us? Well, it wouldn't tell us a whole lot. Okay, so just because these quantities here are numbers, we can compute averages for those. We can do that quite easily in a spreadsheet, but that average doesn't make any sense to us. Okay, so here, computing an average for sex does not make much sense. So again, the spreadsheet is going to allow us to compute the average, but whether or not that quantity makes any sense is something different. So when we were talking about categorical variables, which is what we've done up to this point, then we did a lot of counting of that data, and we looked at percentages, and we looked at bar graphs, etc. When you're talking about numerical data, there's a much wider spectrum of summaries that are appropriate. In particular, there's various characteristics that are of interest to us. And some of those characteristics, include measures of location or position, measures of spread or variation, measures of shape, and then measures of outliers or unusual observations. So we're going to consider here in section 5.1 measures of location and position. We're going to first consider the snowfall data. Okay, and this data set just includes snowfall amounts for various weather stations across the state of Colorado. Okay, and these data were obtained over a long period of years. The data also includes a monthly breakdown of the snowfall amounts. So you can see here from column H through S actually contain the snowfall amounts for the different months. These weather stations were placed all over the state of Colorado. That's what's being indicated here. And then the image on the right is just the various county names for the different counties in Colorado. So if we look at the Colorado snowfall data, just posted on our course website, I'll go show you what that looks like here. You can see that here. We have the station ID, then we have the county, we have the latitude and longitude measurements, and then we also have over here the snowfall amounts for January all the way through December, broken out for each weather station. So this first row here just is the annual snowfall amounts for this particular weather station. The second set, okay, would be the annual snowfall amounts for Washington County, for this particular weather station in Washington County, over many, many, many years. Now what we've done over here on the right-hand side is just added those up. Okay, so for that first weather station, you can see that the total snowfall amount throughout the whole year was 105.4. And for that second weather station, it is 30.8. And we've got that total calculated for all these weather stations. I believe there's about 180 weather stations total here. So let's go back and look at a plot of this data. Okay, so snowfall amounts are on a naturally numeric scale. Can talk about differences. And if I have a location that has 0 snowfall amount, then that means there was no snow that fell. Okay, so here's what that plot looks like. It looks like we got a bunch of locations that have between 20 and 60 inches of snow throughout the year, that is. So this is the total here that's being plotted. We also have some locations that get quite a bit of snow. So we have a location here that gets 280 inches of snow. And that's a lot of snow. 280 inches. That's a lot of snow that would fall. Now, there are certain areas in Colorado that are really good for skiing, and some of those are just west of Denver. I don't know if these locations here that are pretty high in their snowfall amount, I would anticipate that those are at some of those prime ski locations in Colorado. So let's talk about where this data is located at. And what we mean by that is quantities such as the mean or the median, or even the smallest is a measure of location, or the largest is a measure of location as well. We'll start by talking about the mean or average and also the median. So these are commonly referred to as the 3 M's, the mean, median, and the mode. And I have purposely crossed off the mode here in these notes because we rarely use the mode as a measure of location. So we're just going to talk about the mean, which is just the average, and also the median. Now to compute the mean, as you probably know by now, is just to add up all the data points and divide by however many you got. And then the median is just the middle value in the data set after you've put those in order. Now we're not going to worry too much about computing these quantities, but instead we're going to worry about why would we compute these quantities and the interpretation of these things. So how do I get these things in a spreadsheet? You can use the average function to compute the mean or the average, and you can use the median function to compute the median. All I need to do is find an open cell and just in that cell type equal average and then highlight the cells that you want to compute the average of. So I've shown that here on page 3. You can also do the median as well. Just use the equal median function and again highlight the cells that you want to compute the median of. So let's go over and do one of these. Let's go do the median maybe in our data set. Just go over here to an open cell. Let's go off to the right hand side here. And let's go ahead and get the median. So to get the median, I just need to simply type equal median. Use the parentheses again because this is a function. And then just highlight the cells that you want to compute the median of, which are the cells in column D there. Excuse me, T, which is the total column. I need to go all the way down here to the bottom. And go ahead and hit enter. And that quantity is returned to you by, so equal median T2 through T181. And when we compute that quantity, we get 46.45. So again, when all of the values are ordered from smallest to largest, the middle value in that ordered list is going to be 46.45. You can do something similar for the average. So why do we use an average, or why do we use a median? Well, the big picture is we do this to condense or reduce our information down to a single number. Okay, so I'm going to take all of the observations here. I had 180 observations from all the different weather locations, and I'm just going to push that down into a single number. So when I do that for the average, I get 64.7 or so. Okay, so it's just a condensing of that information. Now that condensing of information down into a single number has advantages. For example, if I talk about these 3 counties here in Colorado, and I want to know how different the snowfall amounts are for these 3 counties. I have Grand County, Larimer County, and Otero County, it looks like. And I want to know how much more snow does Grand County get than maybe the others. If I worry about individual observations, that's hard to try to quantify. Okay, so we try to just obtain a pattern or a trend in this data. We're going to take these 4 observations from Grand County and condense that down into a single number. And these set of observations that I have from Larimer County and condense that down into a single number. Certainly the snowfall amounts in Otero County, not sure where that county is located, but it's in a location that doesn't get much snow throughout the year. That's going to be substantially less than either one of the others. But how much less? Well, if I condense this information down into a single number, then it's really easy to see that Grand County I had about 120, and Otero County I only had about 20 inches of snow. So Grand County gets about 100 inches more of snow. Okay, so when we're just talking about patterns and trends, it's nice to take this information and condense it down into a single number. And that's why we compute averages. Now, when we compute the median, as I said, we just take the data from smallest up to largest, and we simply just cross off the largest one, cross off the smallest one, cross off the second smallest, cross off the second largest, and just keep working our way down into the middle. So by definition, the median is guaranteed to be the middle point in the data. When we talk about the average is thought to be the balance point in the data. So if all of the data weighed the same amount, if you were to put it on a teeter-totter, then the average here would be the balance point in that distribution. And you can see that the amounts have, the total snowfall amounts, kind of drift off to the right-hand side here. So let's move down to page 5. You can see that the snowfall amounts kind of drift off to the right-hand side here. We actually call that skewed to the right a little bit. And what that does is it makes the balance point in the distribution have to increase a little bit. Okay, so the mean or the average may or may not be near the center of the distribution. Oftentimes it is considered a value or a measure of center or a measure of typical. But if I have data that has long tails like this one here, that measure of center actually gets pulled up a little bit. So in this case, I actually have a somewhat of a difference here between the mean and the median. It's about 20 inches different. Now that's quite a bit considering that I'm talking about numbers around 50 and 60. So having a difference of 20 is pretty large here. Now, another thing to think about is that one observation, just a single observation, can really mess up an average. We actually call this the breakdown of a statistic. When does a statistic break down? It just takes one observation, kind of one rogue observation, to go off out here into La La Land. Okay, and that's going to have a profound effect on the average. So every observation in some sense is tethered to the average. Or maybe the average is tethered to every observation. So if I have data that has outliers in it, okay, data that may be very extreme, either on the high side or on the low side, that's going to have an effect on your average. However, that observation is not going to have an effect when I compute the median. So that observation can go off to the right-hand side here out in La La Land, but when I compute the median, it is the first one that gets crossed off. So in that sense, the median is not tethered to any one particular observation. So when the government, computes things related around incomes and also around home values, they often will report the median income value or the median home value. And the reason they're doing that is a more fair measure of what's happening to this, or what is the center of the distribution, especially when we have outliers present. Okay, here are just some spreadsheet tips. I will let you look over those. One of those is naming a range of cells, which is pretty convenient. So up above, what I did is I actually highlighted all of the cells. I think I went from T2 down through T181 or something. Well, I can actually give that range of cells, as is shown here, a name. And I just do that under Data and then Named Ranges. Now, this is in Google Sheets here. And then when I want to compute the average of that set of data, all I need to do is type equal average and then just the snowfall total, or the name that you've given that range here. So that saves highlighting the different cells inside of that formula. This is actually a better way of doing it, because sometimes when you're highlighting, you might go too far down or not far enough when you're trying to compute those quantities. The other way of getting averages is through the use of a pivot table. And this is a very powerful and convenient way to summarize data in a spreadsheet. Maybe I'll take a moment here and go over into our spreadsheet and show you how to use a pivot table to get this done, just because it is pretty convenient. So to get a pivot table, let me first clear out this data here. To use a pivot table to compute summary measurements, what I need to do is just underneath data here, let's go back here, underneath data, select pivot table. And what this does is it creates actually a new sheet. So down here across the bottom, you can see that I have a new sheet called Pivot Table 2 being indicated here. And I can construct a table here. It allows me to construct a table, a summary table of sorts. Over here on the right-hand side, I got the Pivot Table Editor. I can add rows and columns to this table. I can also add values, and that's what we're going to do here. So let's go ahead and select Add under Values. And I want to actually summarize the total. So I'm going to select Total from the drop-down menu. Now it's going to ask you, well, what do you want to summarize by? The default here is the sum, but there are other options here as well. Okay, so if I go ahead and page down here, slide down in this menu, do this here, there we go. You can see that I get sum as the default. I get some count quantities. I can get an average here, minimum, maximum. Later on, we're going to be talking about standard deviations, so we can get those inside of our pivot tables. So let's go ahead and just ask for the median here. Now, when we computed the median with the formula, I think I got the quantity 46 or so. Okay, so over here in our table, once I've selected median here, if I go back over into our table, you can see that that quantity has been computed automatically for me. So again, what I did here is specified what variable I want to summarize, which was the total column, and then what summarization do you want to use here, and I'm doing the median here. If I wanted the average, I would just say average there, and it would change it to the 64.7 number that we computed earlier. Okay, so that's a convenient way of getting summaries inside of a spreadsheet. And these can be done in Google Sheets and also in Excel. It's done in a very similar way. All right, let's go ahead and consider a second example then. In this second example, we're going to look at wind speeds, again from a variety of weather stations, here across several states in the western United States. So this data, again, is posted on our course website, and it's the Western U.S. Wind Data Set, which I've already put here. Okay, so here I have wind speeds, again, across all the different months here. Different states, I have data from Alaska, California, Oregon, Wyoming, I have looks like about 450 different weather locations here. Okay, and the setup of this one is, suppose that you're in charge of helping to identify where you should build a wind farm, or where are the windiest locations here in the western United States. Well, one thing that I can do then is just use the average, okay, to go ahead and look at what's going to happen throughout the year. So if I'm going to build a wind farm, I'm going to want to make sure that it's fairly windy, not just in one particular month, but kind of throughout the year. So I want to condense this information down into a single number. And I'm going to do that through the use of an average. Okay, so what is the average wind speed at this particular location throughout the year? So let's go ahead and create a new column over here. And I'm going to call it the average column. And I'm just going to compute equal average, this data right here. So it's equal average D2 through O2, it looks like. And I can see for that particular weather station, the average wind speed throughout the year is at about 6.55 miles per hour. Okay, so if I did that pretty quickly, but if I just get that in there correctly, put my cursor back in there, and if I double click on that lower right hand corner, it'll autofill the average for all the remaining. Okay, so it autofilled here all the remaining weather stations for me. So this one right here is pretty high. That's the Barrow Airport in Alaska. The average wind speed throughout the year is about 12.5 miles per hour. Here's another one in Alaska, the Birchwood Airport. That one doesn't look like it's got very good wind speed here. Okay, let's go back to the notes there. So I'm just using the average quantity to kind of condense this information down into a single number. And I can plot those. Okay, so here on the top of page 8, I've just taken those quantities, those averages there, and just plotted those on a dot plot again. You can see that a typical wind speed is about maybe 6, 7, 8 miles per hour here. I could compute an average of those averages, I guess, if I wanted. Or I can compute the median of those averages if I wanted to talk about the typical wind speed in these states. We can do other things as well. Here I probably would want to just indicate the locations of these high areas where the wind speed's actually pretty high. So these on the upper end are probably consideration for a wind farm. So I can use what they call a filter in a spreadsheet to accomplish that task. Okay, so what a filter is just a way to be able to view certain cells that meet a condition. So here what I've specified is I just want to look at the weather stations that have an average wind speed, okay, greater than, looks like I've selected 15 miles per hour here. So those are going to be observations that are up here on the right-hand side of that distribution. Okay, so let me show you how to apply that filter quick. So here I just want only the cells or only the rows, which are weather stations, for which the average wind speed throughout the year is greater than or equal to 15 miles per hour. So let's go back over and apply a filter to this data. Okay, now to get a filter done, okay, I go underneath data and then create a filter. And what that does is it gives us a little drop-down menu here for every single variable or every single column in your spreadsheet. So let's go ahead, because I want to filter on average here, I'm going to select the drop-down menu over here for average. I'm going to filter by a condition here. and I want greater than or equal to 15. So I need to select greater than or equal to here. And then what value do you want to use? Well, the cutoff value there is going to be 15. And then go ahead and select done here when you have that, or OK. And what that does is it is just, so what the filter has done is it is just showing me the rows that satisfy that condition. So these 10 or so rows, are weather locations where the average wind speed is at least 15 miles per hour. Okay, so that's applying a filter. And if you want to turn that filter off, a couple of different ways that you can do that. You can just go back underneath data here and say turn off filter, and that will remove that and show you, it'll go back to showing you all the rows in your spreadsheet. So let me go ahead and turn that off at this point. The other thing that I want to show you is that we could use the pivot table to create kind of a summary across the different states. So like which state tends to be the windiest. All right, so what I want to do is compute a summary measurement, okay, on these averages. So I've already done one summary measure, but I want to do another one over the top to figure out which state is the windiest. So I would take all of these Alaska numbers and compute an average of those. Okay, so doing a summary measurement on top of an existing summary measurement. That's actually somewhat common. Okay, so let's go ahead and do that. So I can do that easily with that pivot table feature. So what I'm going to want to do on the pivot table feature here is, again, under values. Oops, what's happened here? I think what happened, let me go back to my data a minute. What happened here was I had one particular cell highlighted. So let's go back here and just select the whole sheet. And I can do that up here in the upper left-hand corner. Pivot table. Now you can see I get all of those variable names, and I want to work with the average there. And what I want to do there is compute actually the average of the averages, as I just stated. Now what's happening right now in my table is it's doing that for all of the rows. So this 7.85 is actually the average wind speed for all of the weather locations there. It's the average of the averages, I guess, technically. But I want this number broken out for each state. So what I'm going to have to do is specify that the state as a row variable. So if I add state in as a row variable, it's going to take that average and divide it out for me across each of the states here. Okay, so I did that pretty quickly. Let me show you how that was set up again. Underneath the row box, I want to add state in there. You can see that's been selected there. And then underneath the values box, I want to select the average variable, or that variable way on the right-hand side that I created. Okay, and from here, we can see that Hawaii tends to have the highest average compared to the other states. The lowest looks like it might be Idaho, is it? Is that 6.65 the lowest? Looks like it. Or here's another 6.52, Oregon. So Idaho and Oregon aren't necessarily as windy as some of the other states here. All right, I believe I have a couple of questions here in the notes regarding that, so let's go ahead and take care of those. So which state tends to have the most weather stations? whose average wind speed is greater than 15 miles per hour. So if we look at that list, just look at the states here. Looks like Alaska has many of those. So what is that? 2, 4, 6, 7. 7 of the 11, I think, that are there are from Alaska. So most common state is Alaska. Has most of them there. Let's go ahead and do our highlighting there. Which weather location is the windiest? So this isn't the state, but which weather location is the windiest? So, excuse me, we'll have to look down these. I have, what do we got? Here's a 19.61. Which one is that? Tin City Airport in Alaska. That's the average wind speed throughout the whole year. That's pretty windy there. Now, certainly some months are going to be windier than others, but the average over the whole year there is 19.61. Here's another one that's pretty high, 19.16. Monarch Pass in Colorado is also pretty high. So which weather location is the windiest? Was it Tin City Airport in Alaska, and also Monarch Pass in Colorado is also pretty windy. So those pretty close to each other there. Which state tends to have the highest average wind speed? Okay, as we just said, Hawaii here has the highest. So I'm doing that by state there. Okay, so these are being split out by each state. This other number here is just the number of weather stations there. So I can get that by just adding another variable underneath the values. So you can have more than one quantity being computed underneath the values box in that pivot table. So there's 12 weather locations in Hawaii, and the average wind speed across those 12 is 10.54. Okay, so which state tends to have the highest? That is Hawaii is the highest, a little over 10 miles per hour. Okay, that second part of that question, does your answer above agree with the map that was drawn? So way up here at the beginning of this, I gave you a map here. There we go. So looking at this map here, whiter values are smaller wind speeds here. So states that are more white are smaller, which certainly Oregon here is pretty white. And then the darker the state, the higher the miles per hour, or the higher the wind speed, excuse me. And Hawaii here you can see is the darkest of any of the other states there. Okay, so a lot of times you'll see maps that look like this, and they're just, oftentimes these maps are based on things like averages, like I've done here. So yes, this agrees with the map. So let's go ahead and finish that one. Okay, how about the next example here? So here we're going to talk about percentiles a little bit. So these are measures of location, but not necessarily the center. And I'm going to look at some county level census data here. So that data is also provided on the course website. It's the U.S. Quick Facts data. I have a copy of that over here as well. There's lots and lots of data here because this is the Quick Facts data here is presented for every county in the United States. So I think there's almost 3,000 rows in this particular, over 3,000 rows in this particular data set. We're just going to look at the data from Minnesota. So I guess the Minnesota data is going to be in here somewhere. Or better yet, probably the best thing to do is just to apply a filter on that data. And then you can just see the Minnesota data. Okay. So here on page 10 of the notes, you can see that I just put a filter over the top of that data, and I'm filtering on the state, and I'm just saying I want just the Minnesota data. So From this little box underneath here, you can just select certain states if you want. Now I'm going to be looking at, or the investigation here is going to be centered around household income. So how much income, a typical amount of income for people in this particular county. And again, this is based on medians is how that is computed. It's how the Census Bureau does that. So this is the median household income. So for example, here in Anoka County, the median household income is at about $69,000. Okay, the one above it there, Atkin County, that's quite a bit lower there. That's a more rural county. Anoka County is around the Twin Cities, but Atkin County is a more rural county, and that's somewhat lower there. Their median household income is somewhat lower there. How about the definition of a percentile? Well, a percentile is the pth percentile, let's say, of a set of measurements is defined to be the point in the data where p% of the measurements fall at or below. Okay, so when I look at this data here, if I want to talk about the 0th percentile, okay, that's going to be the smallest value in my data set because no data falls at or below, no data falls below that point. So the 0th percentile here is the minimum. The 100th percentile is actually the maximum value in a data set. The 50th percentile, what that means is that you've made it halfway through your data. And that's just another name for the median. So the median is actually the 50th percentile in a set of measurements. Now we can compute other percentiles as well. So for example here, what is the 10th percentile? So for the median household incomes across the state of Minnesota here, okay, the 10th percentile is at about $43,000. Now what that means is that 10% of the counties in Minnesota have income values lower than that $43,000. If I move up to the 20th percentile, okay, the 20th percentile is at about $44,500 roughly. So 20% of the counties, 20% of my data values, sit at or below $44,500. And we can go all the way through that entire spectrum there. Now, as I've said, the median is the 50th percentile. So that's right at about $48,000. So $48,000 is the median household income across the entire state of Minnesota. For all, I think there's 87 different counties here. Now, oftentimes we'll take these quantities and we'll just plot those on a scatter plot. Okay, so income is going to be on the x-axis, and the y-axis is just going to be on the y-axis will be the percentiles. And that's what we have right here. So income across the bottom and percentiles on the y-axis here. And this particular plot is called a cumulative density function, or a CDF plot. And in my opinion is one of the most underutilized plots that we have in statistics. These things are pretty informative, especially if I want to compare incomes across different states. But before we do that, let's go ahead and just consider the CDF plot for the counties in Minnesota. And again, these are just a plot of these quantities provided here in this table, where income is on the x-axis and the percentiles up on the y-axis. So let's interpret this CDF plot. Well, at the 0th percentile, so that's across the bottom here, that would be the smallest income or the lowest income per household. So I have a county which is at 35,000. So if I go here 0, it's at 35,000. So there's a county in Minnesota whose household income across the county is at $35,000. Now the 100th percentile is going to be the maximum. So that's up here at the top. If we move over till we hit the line, okay, we hit the line at about, what is that, about 85,000 or 84,000 or so. Okay, that's the upper end. So I have a county, there's a county that sits right here, whose household income okay, is at about $85,000 or $84,000. So the incomes range from $35,000 up through $84,000 across the state of Minnesota. Now again, we can come up here and look at that. Sure enough, the smallest value is at about $35,000, and the highest value here is about, well, I said 85, but it's closer to 83,500, I guess. So this shows me where the smallest is at, shows me where the largest is at, shows me where the median is at. So the median here is at the 50th percentile. So I can just go across at the 50th percentile and drop down, and we can see that the median was about 47,000 or so. So again, just go straight across on this line and drop down. It's at about $47,000. All right, let's go ahead and take some of the questions down here. So we just did the median, I guess. What is the median income level per household for the state of Minnesota? I'm going to guess that it's at about $47,000 or so. So we just, the 50th percentile line, go across till we hit the curve, then drop down. And we drop down here at about, what do we say, $47,000 or so. I guess we kind of answered that second question in the first here, so I'll just copy my answer for that one. Certainly, if we have the list of the numbers, okay, we can go right here and grab it off of the table as well. So 47,959 if we wanted to be real exact here. From the table, we got 47,959. Certainly the idea of a graph here is just to get a general trend of what's happening. What's the minimum income and the maximum? Well, we just did those as well. The minimum income was $35,000 about, and the maximum was up here at about $83,500 or $84,000, I guess it was. So let's go ahead and put those in there. $83,500 or so. Okay, let's take care of the next question here. The CDF plot has a longer tail on the upper end than compared to the lower end. What does this imply about income levels in Minnesota? So notice up here that the upper end of the distribution has a kind of trails off to the right here, whereas the lower end is a little bit less, doesn't have as much of a tail. Now, what this upper end means, so let's consider this, let's look at 80% here. So 80% of the counties in Minnesota have incomes less than about, looks like about $55,000. 20% of the incomes are up here above that, right? If 80% are less than that, then that leaves 20% of the counties up here in the upper side, excuse me. Now that top 20%, okay, those range from 55 clear up to 85. So there's a pretty big range of incomes there across those counties. Whereas on the lower side, on the poorer counties, there's not nearly that same amount of range. The range on the lower side is only about, what is that, about 10,000 or so. Okay, but on the upper side, it's about 30,000. So the richer counties in Minnesota, okay, they tend to be kind of all over the board in terms of how rich they are. So that's what that longer tail is telling me about. So what does that imply about the income levels? So let's go ahead and the longer tail on the upper side suggests that counties, the rich counties, I guess, tend to be spread out some in terms of their income levels. This is not the case on the lower end. These counties are much more similar in terms of their income levels. Okay, how about this last one here? The CDF plot is fairly steep between 45 and 55,000. So let's go back up and look at that CDF plot again. Between the 45 and the 55, I guess. So what does that mean if it's real steep in there? So here between 45 and 55, we're talking about this window right in here, between 45 and 55. Yeah, that curve is real steep in there. So at 45,000, I'm at about 20th percentile here. 55,000, we said we were at about 80th percentile. So if I go from 80 down to 20, that's 60% of the people. So 60% of the people are stuck here between $45,000 and $55,000. So a majority of the counties have income levels there between that 45 and 55,000. So if this curve was actually straight up and down, okay, if it was completely straight up and down, then everybody in the state would be making the same amount. So imagine if this curve just started down here at 50,000 and ended up here at 50,000, so it was completely straight up and down, then we would say everybody in the state is making that $50,000. Or all of the counties, I guess, are at that $50,000. So if it's real steep here, it just means that I got a lot of people in that window. So what this means here is there are a lot of people, or a lot of incomes, a lot of people, or counties, I guess, technically, in this range of incomes. Would we say about 60% of the counties are within this range? All right. I'm not going to show you how to compute the percentiles, but here is on page 12, or 13, excuse me, I do go through and show you how that is done in a spreadsheet. I'm just not going to go over and do that there. You just use the percentile function. You need to first identify what percentiles you want computed, then just use the percentile function. Copy that down for all of the cells. And then to actually get the CDF plot, you just make a scatter plot of that data and then connect the dots, and you'll end up with a CDF plot. Now, as I said a couple of minutes ago, the real advantage of these is that your ability to make comparisons across different like states, for example. So when I'm looking at the incomes in Minnesota, that's the one we were considering, the average or median, was about 48,000. That actually looks about the same as Wisconsin. The middle of that is at about 48,000. And I'd also say Virginia is also kind of in that range as well in terms of a typical or middle value there. But one thing that is different about the Virginia is that the points are spread out a lot more in Virginia. Okay, and these are income levels here. So I have a bigger problem with income disparity in Virginia than I do in Wisconsin or in Minnesota. So the averages tend to be about the same, or the centers tend to be about the same. But I got some people in Virginia that are quite poor, some areas or counties that are quite poor, and then I also have some other counties in Virginia that are quite wealthy. They're much more wealthy than they are in Minnesota. So let's go ahead and take care of a couple of these questions. What differences exist in the income per household across these states? So we just kind of referred to some of that. So let's go ahead and type that up. The incomes in Virginia are much more spread out, We have more lower values and more upper values and more higher incomes, I guess would be the right way to say that, than Minnesota and Wisconsin. Minnesota and Wisconsin are much closer together than Virginia. All three states have about the same middle value, or at least close. I guess I said about the same, so I guess that's true. So as I just said here, the Virginia dots are more spread out. Practically speaking, what does that imply about income levels in Virginia? Well, it means that they're much more dispersed. Is one way to say that. Let's see here. Income levels are more dispersed. I guess there is more income disparity in Virginia than in Minnesota and Wisconsin. So I have some counties again that are quite poor. Some, quite a bit more poor than Wisconsin and Minnesota. And this one was way down here. Looks like it's less than 25,000 or so. And I also got some very wealthy counties, as I said a moment ago. So one thing that we could do is just take that data and condense it down to a single number. So I could get the average for Virginia, which is about 48, 49, 50,000. Get the average for Wisconsin, the balance point in there, and get the average for Minnesota. But when I do that, it looks like those income levels are pretty similar across those three states. All right. However, when I do that condensing of that information, I'm actually condensing that information too much. I'm missing some interesting characteristics in that data. In particular, that Virginia has a lot more income disparity than the other states. If I look at a CDF plot, I'm able to pick that up. Okay, so the CDF plot here, I have Wisconsin, Minnesota, and Virginia listed here. Okay, the Virginia is the one that starts lower, as we would expect. Okay, and then once it gets kind of on the upper end, it tends to have tends to have higher incomes on the upper end. So this direction to the right here, the x-axis again is income. So higher up on the x-axis means you have higher income. All right, and to the left means you have lower incomes. So let's look at these questions here. Just about done, so hang with me. Consider the poorest people in each state. That's going to be down here on the lower end of the income levels. In which state is the income levels the lowest for this population of people? So this is Virginia, is the dotted line. Virginia seems to trail behind Minnesota and Wisconsin in terms of the poorest people. And it's a pretty big gap there. I mean, we're talking about maybe close to $10,000, $8,000 gap here, down there on the lower end. So when you're talking about the poorest people in all three of these states, okay, the Virginia, they tend to be about, whatever that is, $8,000 to $10,000 poorer than the poor people in Minnesota and Wisconsin. Okay, so let's maybe make that comment. The poor people, again, these are really counties, the poor counties. The poor people in Virginia tend to have incomes about $8,000 to $10,000 less than the poor people, counties in Minnesota and Wisconsin. On the other end, okay, the rich people, if you think of the richest here, the richest people in Virginia are at over $120,000 household income. Okay, whereas in Wisconsin, that falls way back to $70,000. So the richest people in Virginia are substantially more rich than those in Wisconsin and also in Minnesota as well. So the rich people in Virginia are higher than the rich people in Minnesota and Wisconsin. How about Minnesota and Wisconsin? Well, Minnesota and Wisconsin look really similar. Okay, there's a slight difference, I guess, on the poorer end for, what is that, Wisconsin, but not much. We do get a little bit more separation here in the top 20%. So the top 20%, this is the richest people now, the richest counties. So we can say that the richest counties in Minnesota tend to be a little bit more rich than the richest counties in Wisconsin. So generally speaking, though, they're pretty even or similar. The richest people or counties in Minnesota are have a little more income, are a little higher, I guess, than the richest people in Wisconsin. Now, one thing that we need to think about is just these locations of these counties. So the Twin Cities area, okay, is where a lot of this wealth is at. We have a larger metropolitan area, the Twin Cities, or at least the number of counties, I guess, is a better way to say it. We have more counties in the Twin Cities area or in those richer areas, okay, than Wisconsin does. So Wisconsin certainly has some richer areas in the state, but there's not as many counties that are there. Okay, so down around Milwaukee and Madison, I would anticipate are where these richest counties are at. In the Twin Cities, there's, what is there, I think 7, 8 or so, maybe even 10 counties that are around the Twin Cities. So that might indicate why that's pulled up a little bit more. So what is an advantage to using a CDF plot? Well, the big advantage of using a CDF plot is that I get to see the entire spectrum of the measurements. So if I just used the median here, okay, if I just use the averages or the medians, the only thing that I would be comparing is right here where those values are so very close together, right? That's the median there. Right there, those values are really, really close together. There wouldn't be much of a difference, and that's what I seen up here when I looked at this. So sometimes, as I said a moment ago, sometimes when you condense that information, you actually condense it down too much. You got to be careful of that. Whereas a CDF plot doesn't allow us to do that. It's actually showing me the entire spectrum of the data. Okay, so what is an advantage to using the CDF plot? We get to see the entire spectrum of the data from smallest up through largest values. We get the idea of location, so I can get the median, for example. I get an idea of how spread out the data is. Again, looking at the steepness, for example, allow me to do that. Okay, so I get both of those ideas I'm able to get in a CDF plot. And those make those plots pretty convenient, especially when I want to make comparisons across different groups like I've done here. Okay, well that does it for section 5.1. Thank you very much for listening. Well, until next time, bye-bye.